Hello, 30-1s. Welcome to the last lesson in polynomials. What we're going to do here is we are going to fully factor a polynomial, and once we've fully factored our polynomial, we're able to very easily solve our polynomial. Now, these are very long questions, or they can be very long. What I would like you to do when you're doing these questions is keep your graphing calculator beside you. I'll show you what I mean. So a very common question we see on our diploma would say, a factor of the following polynomial is, and it'd be multiple choice. What I want to do for you is I'm going to fully factor this, just in case it ends up on a written question. Now, fully factor this thing. Holy cow. Let's walk through our steps. First thing we do is we look for our possible or potential zeros. So possible zeros. Remember, we look at all of the factors of 24. And guess what? There's a lot of them. Wow. Look at that. That's a lot. Now, what we're going to do from here is we're going to use the factor theorem. What the factor theorem again tells us is we're going to sub in these values. So we're going to use the factor theorem. And we're going to try to find a remainder of 0. By using one of these possible zeros. Okay, but wait, look at all of those zeros. Holy cow, that's a lot. I don't want to randomly check those at all. In calculus next semester, when I don't have a graphing calculator, I might have to. But hey, guess what? We're in 30-1. We have a graphing calculator. So I go to my graphing calculator, and I already have this thing graphed, and I can see right away where my x-intercepts are. My x-intercepts are at -4, -3, and 2. So I'm going to go back to what I was just doing, and I'm going to write that down somewhere so I can keep an eye on it when I'm doing my work. So our x-intercepts are, what do we say? Are zeros, I should say. I'm not writing them as x-intercepts. I'm writing them as zeros. There they are. And I'm just going to kind of write them up there in the corner so I can see them. All right. So I'm going to use the factor theorem. And I'm going to sub in one of all of these possible zeros into my polynomial. Well, maybe I just get super lucky and I just happen to guess x equals 2. What a lucky guess. I am just the luckiest guesser. Now I'm going to show what I already know by looking at my calculator. That this is equal to 0. Again, what does that tell me? What this tells me is this. Therefore, x equals 2 is a 0 of p at x, and almost more importantly for what we're about to do, x minus 2 is a factor of p at x. All right, so what do we do with this now? Well, we need to factor this cubic. So we're going to use what we just discovered to help us factor. Now, we can do this in 2 different ways. We can long divide or synthetically divide. How about I'll do both? So long division, going back to when we were in elementary school, right? Okay, hopefully you've mastered long division by now. So I say, what do I multiply x by to get x cubed? So x squared, x cubed minus 2x squared. What usually goes wrong in these questions is the subtraction. So just be careful, friends. So 5x squared subtract -2x squared is 7x squared. Bring down the next term. Repeat, what do I multiply x by to get 7x squared? That's 7. x, I should have said. Subtract, again, now we're subtracting a negative. So -2 subtract -14, well, that ends up being -2 plus 14. That's 12x. Bring down the next term. Multiply x by 12. And I know that we've done this right because we have that remainder of 0. That's essential. You said that this was a 0. You told me x minus 2 is a factor. It better be. Okay. I could do this using synthetic division if you would like. So now remember, there's two methods to synthetic division. I do the addition method. So the addition method, I would do this. And remember, we take our coefficients like that. Drop down the first term. We go 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. Add those together, I get 12. 2 times 12 is 24. Add those together, I get a remainder of 0. Okay, so that's the addition method. Okay, if you do the subtraction method, sure, I can do this 3 ways. If I wanted to do the subtraction method, it looks almost the same. So depending on how you're doing the question, but the big difference here is you would put a -2 here. So same, drop down the 1, multiply, subtract, that's going to be 7, -14, subtract, that's 12, -24, subtract, that's 0. So it doesn't matter which of the 3 methods we use, friends, we get the exact same answer. We have to. Okay, so what I like to do when I'm doing these questions on a test is actually, my friends, I'm a huge nerd. I am going to do it 2 ways. I'm going to long divide, complete the question, and if I have time, I go back and I do synthetic division. Might as well. Diploma, 6 hours. Might as well take our time. Okay, so what is it we now know? Well, p at x is x minus 2, and just looking right here, we just divided, we were able to drop it down 1 degree to that. So now I say to myself, yeah, I'm getting there. Can I factor this? Well, thankfully on this question, the answer is yes. Sometimes you won't be able to. And what you would have to do in that case is use our old friend, the quadratic formula. However, on this question, thankfully, I can factor that thing. And so look at, I'm going to do a check here. Look at my zeros. +2, -4, -3. Hey, isn't that exactly what I kind of snuck up here right in the beginning of my work? So now I'm going to just erase that because I don't want anyone to know that I was actually doing a little bit of graphing there. Sneaky, sneaky, right? Okay, there we go. This has been fully factored. Now, if the question had said, solve the polynomial, and we had p at x equal to 0, well, it would look more like this in the question. X cubed plus 5x squared minus 2x minus 24 is equal to 0. Okay, if this thing said solve, well, guess what? We have to complete all the same steps that we just did, factor it, and now to solve it, well, we're fully factored, but this time we're equal to 0. So now that we're fully factored, what do I know? Using these factors, here are my zeros. That's it. There's your solution. And if you would really like, what would be excellent is if you would write that as a solution set. There's your solutions. Okay, friends, that is what I need you to be able to do to factor or to solve a polynomial. Again, on occasion, you might have to use the quadratic formula to finish off finding the zeros. My hint that I have to use my quadratic formula when I go to find the zeros is this. Again, I'm always going to graph this thing first. So say I had some lovely looking degree 4. When I go to look at my x-intercepts in my graphing calculator, if I get an x-intercept of 1.41426 ... and it never stops, it's an irrational number here. This right here is my hint. You better be using the quadratic formula. That's it, friends. Okay, take some time, do some of these questions, factor them fully. It'll take you a little while, but that's why you're going to graph it first and make sure you're not making any mistakes. Good luck to you. I will see you in the next unit.